Hello everyone, welcome back to CloudOpsCraft. Today we are going to discuss about Docker interview questions, particularly images, layers, and registry. I have already created part one interview question, recording Docker basics and core concepts. If you didn't watch it, I'll provide playlist link in the in description. Just have a look into it, so you can get a good flow of this interview. So let's start with images, layers, and the first question is, what are image layers? So, interview context for this question should be like this is a fundamental question. Interviewers want to know if you understand how images are built and why images are efficient in storage and distribution. If you can explain these layers clearly, you can explain builds, catchy, and optimization later. So let me explain this. Okay, Docker image is composed of a sequence of layers. Okay? Each instruction in a Docker file creates a layer. Okay? So layers are read-only and stacked. Later layers can add files or override files from earlier layers. Okay? The final image is the union of all those layers presented as a single file system snap. Okay? So here you need to know the key properties. Okay? First key properties is immutable. The thing is, once a layer exists, content addressed by digest. Okay, it does not change. Second is content addressable. Storage systems identify layers by the digest, okay, which is hash. Okay. Second is reused by shared. Identical layers used by different images are stored once on a disk or registry. Okay. Next is layer pair instruction. Okay. The thing is, each Docker file instruction often creates a layer. Okay, so like you can use build kit and optimization can affect this. Okay, but the conceptual model stays. Okay? So the thing is, how you can explain this question in interview is image layers are the read-only building blocks of Docker image. Each Docker file instruction typically creates a layer. Layers are content addressed and immutable. So identical layers can be shared across as images, which saves storage and speed up distribution. Okay, this is how we have to answer for this. Second question is, how does Docker's Union FS help image creation? Okay, so interview context will be they want to know whether you understood the union file system concept and how multiple read-only layers can be presented as a single file system to a container. So let me explain. Union file system. Uh, it let multiple directories, layers be stacked and viewed as one. When Docker assembles as an image, each layer is a directory on disk. Union FS presents a merged view. Okay, it reads check uh, the most topmost layer first to fall back to lower layers. This enables layering, sharing, and a common copy on write behavior. Okay. The major benefits is storage efficiency. The major benefit is storage efficiency because like a common layer, common lower layers, OS, runtime libraries are reused. Second is fast image assembly. Docker can compose images by pointing to existing layers rather than duplicating files. Okay. So third one is atomic updates. Adding a layer is just like adding a reference to new content, not rewriting the image. So, like how you can answer for this question is Docker uses a union file system overlaid to stack image layers and present a unified file. This lets Docker reuse read-only layers and add a thin writable layer on top, which gives fast image composition efficient. So third question is, what happens when you modify an image? Here interview context will be, interviewers want to see if you know image immutability, how changes are and container writable layer versus new image creation, and the recommended workflow. So let me explain. By design, images are immutable, which means you can't like change it. Okay, you don't directly modify an existing image in place. There are two typical ways to change an image. Okay, so the first way is you can run a container and change files in a writable layer. So the first thing is you can run a container and change files in its writable layer. Those changes belong to that container only. The underlying image remains unchanged. If you remove the container, those changes disappear unless you commit or use volumes. Second is you can rebuild a new image. This is the best way. Okay, this is the recommended way. Okay, rebuild a new image. Because if you restart this, it will be removed. Okay, so the best way is rebuild a new image, which is recommended one. Modify the Docker file or source files and run Docker build to create a new image. This yields a new set of layers and a new image digest. Okay. There is also Docker commit, which captures the container current state as a new image, but it's brittle for reproducibility and not recommended in the CI/CD pipeline. So how you can answer this in interviews? Images are immutable. You don't edit them in place. Runtime changes go to the container's writable layer. To change an image reproducibility, you update the Docker file and rebuild. Okay. So Docker commit exists, but it's not ideal for production because it breaks reproducibility. So the next question is, explain copy on write mechanism. Okay. So here the interview context will be, this checks if you understand how the writable layer behaves and why containers can modify files without duplicating all underlying data. Let me explain. Copy on write. COW. Okay, in short, we will call this as a COW. Copy on write. Means like a COW means the system differs copying data until it must be modified. With overlay FS, there are read-only lower layers and upper writable layer for the content. When a process tries to modify a file that lives in a lower read-only layer, the file system copies the file up to the writable upper layer and then applies the modification there. Reads return the upper layer copy if it exits, otherwise the lower layer file. Here implications will be, there are three implications. So while coming to implication, first is efficient, which means no copies until a write occurs. Second is isolated, which means writes are local to the content, upper layer. Third is rollback friendly, which means lower layer remains unchanged. Okay? So if you are unable to understand these concepts, then we have to relearn the Docker. Okay, because these are all the core concepts. Okay? In interviews, they will not ask direct questions. What is Docker file? Can you explain 5 key instructions that you have used in Docker file? Like that, they won't ask. Okay, they will check your in-depth knowledge. So they will obviously they will test your in-depth knowledge. So you must know all this. Okay? If you need a full Docker course from me, just let me know in the comment section. I'll create a full Docker course so you can able to answer all these questions. Okay? So this is okay. These are all the three implications. So the thing is, if I want to explain, okay, consider read only lower layer. Okay, L1, L1 to L2, L2 to L3, layer 1, layer 2, layer 3. Okay, writable upper layer will be U. Just consider U. Okay, process writes process. Okay, writes files. Consider just under app config.yaml. For example, okay, overlay copies. Okay, this app config.yaml from L3 to U, which is copy up. A process modifies the file in U. What will be the result? The containers is modified file, image layers are. So how you can explain this in let me explain. Copy and write means a file from a read-only image layer is only copied into a container writable layer if the container modifies. That keeps storage efficient and ensures the base image remains unchanged while letting containers have isolated writes. So the next question is difference between image and base image. This is easy question. Okay. Here the interview context will be interviewers want to know if you understand the idea of base image, which is starting point, versus any image which could be built on top. So how you can explain? Let me explain first. Okay, concept. After that, I'll help you how to answer an interview. So let me explain. A base image usually refers to the earliest layer in your image inherits from. For example, if you are using from Ubuntu 22.04 or from scratch, okay, these are all the base image. It provides the OS level file system and pack. Okay, the general layer image may be built on the top of your base image and includes your app and dependency. So base image equal to foundation, image equal to base plus additional layers. Okay, your app, your config and build artifact. Okay. For example, if you are starting the Docker file from scratch, what it indicates? Any idea? If you know, let me know in the comment. If you are starting with the from scratch, then what it indicates is, which means no base image. You are building from an empty file system. Okay, mostly we will use this for minimal content. Okay, so how to answer an interview? So a base image is the foundation declared in the Docker file. For example, from Ubuntu or from Alpine. So your image is built on the top of the base image by adding layers with application code and config. The base image determines the underlying user land available package. Okay, so this is how you have to explain. So the next question is how layers shared between images. Okay, the entire context for this question should be they want to confirm you know content addressable storage and how registries host avoid duplicating data. So let me explain. Layers are content addressed as we discussed in previous question, identified by a digest. Digest means hash of their content. Okay. When two images include an identical layer, same files and metadata, both images reference the same layer digest on disk and in registries. The layer is stored only once. When pulling and pushing happens, Docker checks whether the layer already exists locally at the registry. Okay, and only transfers missing blobs. Okay. This is why using common base image example Alpine across as images saves bandwidth and space, okay, disk space. For example, image one. Okay, so I have an image here. I have an image here. So here L1 is base and L2 is runtime. And L3 is app. I have another image called B. Here I have L1 base. Okay. L4 L4 other app. Okay, so L1 stored once on disk and shared by both images. Okay, so how to answer an interview? Layers are content addressed and immutable. You must let them know this. Okay, so layers are content addressed and immutable. So identical layers are shared by reference. If two images include the same base layer, that layer is stored once and referenced by both images, saving storage and network bandwidth. So the next question is, what is a image digest or SHA? You may have this question also, right? While you are like looking into these questions. Okay, let me explain. The interview context for this question should be they check your understanding of immutable identifiers and how to guarantee exact image content. Okay, so let me explain. An image digest option or like often shown as a SHA 256, SHA 256 and so. Okay, so it's a content addressable hash of the image manifest which references layers. It uniquely identifies the exact image contents and it's immutable. If any content changes, the digest changes. Okay, tags will be like a underscore, like a colon latest or colon v1.2, v1.3 like that, or mutable names that point to an image manifest. The digest tells you exactly which manifest and layers the tag pointed at the push time. For example, if I use Docker pull nginx at SHA 256 ABCD summash. This ensures you get the exactly that image, not a possibly updated latest. So you can answer an interview. An image digest SHA is the content-based immutable identifier of an image man. It guarantees the exact image contents and is preferable in production deployments to avoid tag drift. For example, Nginx at 256 it pins the exact image so you can avoid confusion. So the next question will be explain build catching works during builds. Let me explain. The interview context will be like interviewers want to know if you can optimize builds and reason about build catching for CI efficiency. So let me explain. Docker build creates a layer per instruction typically. Docker catches each build step layer keyed on the instruction and its input content. On a rebuild, Docker checks whether the instruction and the relevant build context files referred by that instruction are unchanged. If so, it uses the cached layer. If an instruction or any of the files, it depends on the change, the cache is invalidated for the instruction and all subsequent instructions are rebuilt. So the best practices to maximize cache is first put less frequency changing instances like apt get installed before frequently changing one's copy. Okay, so whenever you write a Docker file, don't start with copy or something. So if you want to install anything, then start with that apt get install and install that software and use copy because copy is frequently changing one. Okay, so and use Docker ignore file to keep irrelevant files out of the build context, and use multi-stage builds to reduce final image size and separate build time from runtime step. In CI, mostly we will use okay while we are working as a while building Docker file, we will use catchy hyphen from. Okay, to pull existing cache from registry and enable build kit for improved caching. Okay, so and we can use even run equal to run equal to not equal to hyphen run hyphen mount equal to type equal to cache for package caches. So always start from base image, and if you want to install any softwares, then install that in a section 2. After that, copy. After that, if you want to run any commands like run npm install like that, you can do it. After that, you can copy source. After that, you can build. So you can answer an interview. Docker catches build layers per instruction. If an instruction and its input context haven't changed, Docker uses the cached layer. To optimize, I order Docker file steps Stable steps OS dips are yearly. OS dependencies are yearly. Use docker.ignore docker ignore and use build like multi-stage builds and build kit features for better catching in CI. Next question is, why are smaller images better in production? So here the interview context will, they will test your system design thinking like performance, security and operational. So let me explain. Smaller images are better because they have because there are some. Let me, first advantage of using small images is faster pull and deploy. Okay, less network transfer time, faster startup and scaling. Second is reduced attack surface. Fewer packages means fewer potential vulnerability. Third is lower storage cost, less disk usage across a registry and node. Fourth is better resource efficiency. Like a smaller layers can be catched more effectively. While coming to strategies, use minimal base image, Alpine or distoless. Multi-stage builds to remove build time dependency. Debug. While coming to trade-off, sometimes you sacrifice fewer utilities for minimal size. Choose what fits your operation. So how to answer an interview? Smaller images speed up deployment and scaling, reduces the attack surface, and save storage and bandwidth. Production, I use multi-stage builds and minimal base image, so our deployment time and security will be improved. Okay, like that you can expect. So the next question will be difference between latest and version tag. So here interview context will be, they aim to check whether you know that latest is not magical and tag semantics. So the thing how you let me explain. Latest is just a tag name by convenience like by often used for the most recent builds, but it's mutable and can point to different image manifest over time. Specific tags like version 1.2.3 are also mutable, but typically used as a stable version. The best practices for production is to pin by digest a specific immutable tags key, like a semantic version plus build number. So deployments are reproducible and avoid tag drift. The important thing here is, if you're pulling image colon latest can lead to non deterministic results. The tag has been updated since your last day. So how you can answer an interview? You can say latest is just a tag. It's not a special or guaranteed mutable. For production, I avoid latest and use version tags or digest in the exact image to ensure repeatable deployments. So the next question will be how can you roll back to previous image version? Here interview context will be, they want to know if you have a rollback strategy and how images and registers fit into. So here let me explain the rollback option. There are several rollback options. First is redeploy a previous image. Okay. Example, image version 1.2. If tags are used, respond. Second is redeploy by digest. Okay. So to guarantee exact image, it's recommended one. Third is registry support. Uses the registry UI and API to find order manifest. So next is immutable artifact pipeline. Stores artifact metadata on the digest in your deployment when Helm chart, Terraform, Kubernetes deployment. Next is fast rollback. Keep previous image version available in the registry, and in orchestration systems like Kubernetes supports rollbacks in deployment. Yeah, revision history. The key practice here is CI should produce immutable artifact, image plus digest, and record them in deployment. So rollback is simply redeploying the recorded digest. So how you can explain this in so you can explain like I roll back by reproducing the previous image digest or version tag stored in the register. In Kubernetes, we can redeploy the peer deployment division or apply the previous image digest to ensure rollback, exact roll. Keeping CI artifacts immutable makes this reliable, like that you can explain. So the next question will be, what happens when you push an image to Docker Hub? So here the entry context will be they want to ensure you understood the push and upload handshake, layered upload and the manifest publishing. So let me explain. So when you run like a Docker push my repo as my image, for example, the Docker D first what it will do will authenticates with the registry using Docker login credentials or second, what it will do, it will compare lower layers with the registry. It compares local local layers with the registry. Okay, it checks which layer blobs the registry already by digest. Third one is upload missing layer blob. Uploads missing layer blocks. Transfer each missing layer of parallel or chunked as binary blobs. And next one, upload the manifest. Once blobs are present, the client uploads the image manifest, which references the config blob and sets the tag to point to that. Next is registry stores metadata. Registry indexes the manifest and returns it. If the layer already exists at the registry, it is not re-uploaded. Only the manifest update is needed. So how you can explain in interview? Pushing an image authenticates the client, uploads any layer blobs that the registry doesn't have, and then pushes the image manifest which ties the layer together. The registry then stores the manifest and the tag point. Identical layers are not re-uploaded, which saves the bandwidth. So like that you can. So the next question is, can you store private images? Yeah, entry context will be interviewers. They will check whether you know options, private register, access. So yes, there are several options there. First is manage private register. Find all the possible answers. Uh, Let me explain this. Managed private register. Docker private repos, AWS ECR, Google Artifact Registry, Azure Container Registry, GitHub Container Registry. You can even use for managed private registry. Second one is you can go with self-hosted registry. Okay. Like Nexus, Artifactory, Registry, Arbor, like that. There are so many self-hosted registries. Third one is access control. Uses token-based auth, IAM roles, or LDAP by AD integration. Configures TLS to secure transfer. Fourth is authentication in CI. You can use Docker login with the secure secrets or CI native auth helpers like ECR login via AWS credentials, GitHub Actions. OIDC. And even you can do network controls. VPC endpoints, firewall rules, and private endpoints to keep images internal. So, how to answer an interview? Yes, private images are stored in private repos like ECR, ACR, or self-hosted hardware. Like we secure access with the token-based auth, TLS, and integration using short-lived credentials or I. So only authorized systems can put images. So the next question is how to secure image distribution. Here, interview context will be this tests operational security knowledge like signing, scanning, transport security, and deployment policy. Okay? So let me explain. Key measures to secure images is first is transport security. It uses TLS for registry endpoint. Second is authentication and RBAC. Restrict who can push and pull via tokens, IAM, and third is image signing and provenance. Docker content trust notary or newer tools like cosign, TUF, or SBOMs. Okay. Verify who built the image and that it has not been tampered with. So, and the fourth is vulnerability scanning. Integrate scanners, we like that in CI and registry to block known TVE. And the fifth is immutable tag and allow list. Pin images by digest and maintain an approved image list. So sixth is so these are all the ways to secure images. So sixth is network isolation. Restrict registry access to internal networks or via VPN and VPC. Seventh is policy enforcement. Use admission controllers in Kubernetes or CI gets to any unsigned or vulnerable image. Eighth is least privilege and secure handling. Like avoid baking credentials, use runtime secret. How to answer an interview? I secure image distribution by using TLS and RBAC for registries assigning image. Example cosine for provenance. Scanning images in CI for vulnerabilities and enforcing policies to block unsigned or vulnerable images before deployment. Also, we've been digest in first, so we know exactly what's deployed. So the next question is image not pulling in CI/CD. What's your approach? They may ask like this. So the interview context will be this is a troubleshooting and operational scenario to evaluate your method debugging and awareness of common issue. So let me explain. First is reproduce and read error. So how I will approach this my troubleshooting approaches. First I will do reproduce and read error. I get the exact CI job logs and the Docker pull and the kubectl error message. Error text guides root cause like 403 out or 404 not found or 429 rate limit or certificate error. Second, I will check image name and tag. Confirm the registry repository name, tag or digest is correct and it is not has been deleted or re-tagged. Third is authentication. I will verify CI credentials, Docker login tokens not expired, correct registry URL, proper IAM permissions, everything I lent you. Fourth one is network DNS. Check CI runners, network DNS resolution to registry, corporate proxies, firewall rules, or private VPC. Fifth one is registry status and permission. Check registry UI and status Docker hub incidents and registry access is repo is private, all those things. Second is rate limiting and quota. Rate limiting and quota. Docker hub enforces rate limits. Check if your CI is being throttled. And the next, what I'll do is I will check certificate slash TLS errors. If self-hosted registry, check CS test on CI runner. And eighth will be I will check for blobs missing. Sometimes an image push failed, leaving manifesting blobs. Try repushing. Okay? Ninth will be retry and fallback. I will attempt Docker pull locally or from another host. Try pulling by dice. Tenth is logs and escalate. I will collect Docker D logs, network traces, and escalate to registry domain. Okay. So, how to answer an interview? First, I will read the CI error to determine if it's an auth or not found or rate limitation. Then I will verify tag and digest correctness. I will confirm CI credentials, registry permission. I'll check network DNS or proxy issues on the runner and confirm the registry health. If needed, I'll try pulling the image manually, check for partial pushes and escalate with the collected logs. The approach is methodological. Okay, reproduce, identify error class, verify, config auth network, and fix or escalate. So this is a way out. So this is all about this series. If you like this breakdown, subscribe to CloudOpsCraft. We will simplify cloud and DevOps concepts every week, as well as if you want to revise all this interview questions, I will create Medium article also. So you can check my Medium page and revise all these questions. Okay, thank you.